So this problem is about minimum force required to slide a block in a spring mass system. So what we have here is we have a block of mass m1 and another block of mass m2, and these two blocks are attached by a spring and they are placed on a surface, and the surface is not smooth, it has some friction coefficient, and friction coefficient is given. And the masses are also given m1 and m2. A spring constant is given k, and on m2 mass we are applying a force F. So the question says we have to find minimum value of this force which is constant so that mass m1 just starts moving, just starts sliding. So let us read the problem. It says two blocks of masses m1 and m2 connected by a non-deformed light spring rest on a rough ground as shown in the figure. If the friction coefficient on the ground is mu, we have to find the minimum constant force F to be applied on mass m2 so that m1 starts sliding. So how will you do this problem? So let us try to visualize the situation. What will happen if you apply a force F which is constant in this case? It is given in the problem that this force is a constant force. So if you apply a force here, first thing will happen that the friction will resist this force and this block does not want to move. How much will be the friction? Normal reaction will be m2 times g. So you can calculate this friction force. Let's call this friction force as F2, and this will act in this direction. So this friction will resist the motion. But if this force is large enough, then this will overcome the friction and this block will start sliding over this surface. Now once it starts sliding, what will happen? This string or a spring will also start stretching. So once it starts stretching, let's say this has a stretched by a small amount x, then it will start applying a force in this direction. So the motion of block will start retarding. So this block will start retarding. Initially you are applying a force F which will increase the velocity of this block mass m2, but there is a force that is starts acting in this direction. So this force will start deaccelerating this block. So velocity will reach to a maximum, and then due to this force velocity will start decreasing. But at the same time this force will also be applied on this block, that is kx. So this force kx can overcome this friction. Let's call this friction is F1. So we have to find what should be the value of x so that this block will just start moving. Since we have to find minimum force, so what will happen at this point? This will just start to move. This means it will have some velocity v is equals to 0. Now if this block had just started to move, just started to slip, so this spring will have some elongation and this elongation will be fixed. This means if this block has a velocity v equals to 0, then this block should also have a velocity equals to 0. Otherwise, if this block has some velocity, then this will have some more elongation which will further elongate, and in that case this velocity or this x will be not the appropriate x, because x is decided by F1. So once I fix the x, then this velocity, and I also fix this velocity 0, this velocity is already fixed, that this velocity will also be 0. So using all this discussion, whatever we discussed here, let us write equation and solve the problem. Pause the video. So let us try to solve this problem. So in this case, mg force is acting in the downward direction and normal will act in the upward direction, and n is equals to mg. So friction force on this block is basically how much? Mu mg and m1g. At this point of time, elongation in the spring is x. So we can write this just starts moves. So kx is equals to mu m1g. So from here we know x. So x is fixed. That is x is equals to mu m1g divided by k. So this is one equation, and the second equation we can write from the energy conservation. So we can write work done by force F, is equals to, so whatever the work that has been done by this force, that has either stored in this potential energy or it has been gone to do the work in the friction. So this is equals to work done by friction, and this belongs to mass m1 as well as mass m2 both. So work done in friction for mass m1 plus work done on friction for mass m2 plus potential energy in a spring. So let us write these terms. So this work we can write. So this force is displaced by amount x. So work done by force is equals to F times x, and this is equals to work done by friction on mass m1. So on this mass, this will be mu m1g, and this just had started to move, so there is no movement on mass m1. So this term will be 0. And this has moved by x amount, so this will be the second term we will have mu, and normal reaction is m2z. So mu m2g is the friction force for this block. So this friction force will act in this direction, and this will be mu m2g. So this is the friction force plus potential energy. Potential energy will be half k x square. But I know the value of x. So if you plug the value of x, we can write fx is equals to mu m2z plus half k x square, and x we can plug in both cases. So x is mu m1g by k, and here I can also plug this value. So f times mu m1g divided by k. Basically I missed one x here, so this will be force times distance. So this is, so in that case basically I can cancel one x throughout. So what we can do is we can cancel one of the x throughout. So we can have, so if you cancel x, you will have f is equals to mu m2z plus half kx. So this will be mu m2z plus half, and x is nothing but mu m1z divided by k. So k gets cancelled out, so this k and this k cancels out. So you will have mu m2z plus mu m1z divided by 2. So this is the minimum force this is required. Remember, there is no change in kinetic energy. Initial kinetic energy and final kinetic energy all are 0. That's why we can apply this formula, that is work done by the force. This total work is basically has gone to increase either the potential energy, or some of the work has gone into the frictional forces. So now question for you. So this is the minimum force. If you apply this force, what will happen? So this is the minimum force. This mass will just start moving. So this mass will just slip. But what if I apply a force that is greater than this? So I apply a force F0, which is greater than F. So in that situation, what will happen? Will both blocks start moving? If yes, then what will be their velocity? What will be their acceleration? So let us discuss all this in the comment box. And I hope you enjoyed this video. And if you enjoy, please share with your friends, and do not forget to like this video. Thank you.